Welcome to my lecture series on digital signal processing. So here we are basically discuss multiplication of two DFT for long duration filtering sequences, and method here we introduce, that is overlap add method. This is a part of lecture number 12. So lecture number 11 we are discussing about the overlap save method. Here we are introducing overlap add method. Now this is on the problem we are here consider the find the linear convolution using overlap add method of the following sequence, whether xn 1 2 minus 1 2 3 minus 2 minus 3 minus 1 1 1 2 minus 1, and the impulse sequence, that is HN, we are considering as 1 2 3. So what are the difference between the previous and this problem? Here we are just consider minus sign in the 1 position of the XN sequence. So almost we are considering the both the sequences the same. So now in overlap add method is a part of the DFT. Is in overlap add I am going to discuss about the detailing of the steps whatever we are follow to find out the final sequences. So here basically we are already discuss about the terminology like L, M and N individually in the previous lecture video. Now if we again little bit we discussed about this term, that is N. Now for the whole DFT we have seen that N point DFT we are actually finding, or we have working with this N point DFT, and you are already familiar with the twiddle factor value also. This is starting from either 0, starting from not a 0, starting from in 2 to the power n term, that is 4, or maybe is considered as 8, or maybe is considered as a 16 point DFT. So basically it is a power of 2 to the power n, and considering n value, that we can write down that n equals to 4, 8, 16, so on. So now for this particular problem, if we solve, here we consider, here we are assuming that n equals to 4 for reducing the complexity of the whole calculation. Now we just directly come with the formula where we are considering. Before that I am just telling you, so previously you remember, if we consider the each block, because here we consider n equals to 4, that means we are considering the each block for the calculation. So previously we say that this is m1 minus 1 and L. So if we consider this both block, then the length considered as the n. So here we consider the first block considered as L and second block m minus 1, isn't it? So now you already know m is basically the length of the impulse response, that is Hn length. We are considering as a 3, and we are already assuming n equals to 4, and finally we find out, and similar way to previous overlap save method, that is L equals to 2. Now what about the algo? We have say that I already discussed this part. If we consider the total length is n, so inside the n we are considering two separate blocks, that is L and m minus 1. So L is basically number of split data considered from the long distance signal sequence, that is xkn. So that means the length of this L is basically 2 and M1 is considered as the apparent padding 0. So you remember in the previous case, when we are considering the overlap shape method, that time we are considering the m-1 number of previous sequence and L is the current sequence we are considering. In case of the first sequence, we are considering that m-1 there is no previous sequence, that's why we are considering the 0. But in the overlap add method, we are always considering m-1 number of zeros and L is the current xk sequence. It's a part of the xn sequence. Here we write down that the total sequence xn, if we consider, then we are splitting sequence considered as a L1, L2 as like that way. Here we are considering just a L splitting by the L, and x1n we are taken as a 2 sequence and m-1 number of zeros we are considering. So our main sequence, if we consider as a 1 2 as our problem 1 2, that means the first x1n considered as 1 2 and then the next two sequence considered as zeros. Similarly, if we consider the second sequence, same thing here we follow, -1 2 consider as the x2n sequence and m-1 number of 0 we are considering. So similar way to write down up to total number of sequences are present is the 12. That means we are subdivided by the 2 because L considered as a 2 and then total sequence we have 6. So x1 into x6n. So let us see the total split input sequence xkn consider as, I already mentioned that s1n, that is 1 2 0 0 x2n, -1 2 0 0 x3n, 3 -2 0 0 x4n, -3 -1 0 0 x5n, 1 1 0 0 and x6n, that is 2 -1 0 0. Now same process here we also follow as overlap shape method. What we are doing, that is circular convolution. So perform circular convolution of hn and block of xkn, that is y1n considered as a x1n circular convolution of hn. So similarly here we write down up to y6n x6n convolution with the hn. So now we perform the circular convolution method we are following. So you know the several methods are there, that is a DFT, IDFT method. You can implement it. You can implement it concentric circle method, but here we are implemented because of the complexity. We lays down the complexity. So here we are considering, here we are implemented the matrix multiplication method. So basis on the circular convolution, here we are just first write down this part and then we write down the two matrix and then we multiply and finally we get the value that 1476. Similar way to other part, if we consider y2n, we are getting the value using then again using the circular convolution using the matrix multiplication method, we get the value that -1016 y3n 3456 -6 4 y4n, that is -3 -7 -11 -3 y5n, that is 1353 y6n 2343 4 minus 3. So after that, now we are applying overlap at method. The algo, what they said, that first two sequence of the output we are considering. For the first, that is, if we considering this is y1n and y1n having a two separate part, one we are considering y1n, one another part is m minus 1, that is means the 2. The total length is 4, 2 and 2. So first two consider as the output and second two will be added with the second sequence. First two sequence we are added, isn't it? So now we just directly go for the sequences. So first sequence we are considering 1 2 1 4 7 6. For 1 4 we are considering directly the final output data sequence, part of this final output data sequence. And what about the 7 6? Now we are considering the second sequence, that is minus 1 0 1 and 6. We just add 7 6 with the minus 1 0. It's a parallel addition here. So 7 plus minus 1 means that is 6, and 6 plus 0, that is also a 6. So second sequence considered as a 6 6. So we are just considering the next sequence. If we consider the next sequence, that is 3 4 5 minus 6. So we are here also adding with the 3 plus 1, that is 4, and 4 plus 6, that is 10. So similar way we just get the value of output, that means the final output. So finally in the last sequence, the y6 sequence, here we y6n sequence, here we consider 5 plus 2, that is 7, 3 plus 3 is a 6, and last one we just we are considering, that is 4 minus 3. So you know the linear convolution, this is on the linear convolution, the total length, that is xn length, add with the hn length minus 1, that is, here we consider the this length is xn length is 12 and hn length is 3, so total length is 14. We just check the final output data sequence also the length of 14. And this is the method of the linear convolution absolutely, but here we apply the circular convolution. So this is one of the circular convolutions application, we can say. So hopefully you understand the both the method, overlap, save and add method. Thank you for listening the video.